This is video 2.4 through 2.5 for more about linear equations and using their models. So last video we talked about the slope-intercept form. Slope-intercept form was y equals mx plus b, where m was our slope and b was our y-intercept. Now we'll move on to talking about point-slope form. Point-slope form is when you are given a point and you're given a slope. M is our slope, and the point x1, y1 are what we plug into this x1 and y1 spot. The regular x and y we just leave there because remember all equations of the lines will have an x and a y in them. So write an equation of the line through the points, -3, 5, and 6, 2. There we have 2 points. We can easily calculate slope from our 2 points. If you remember yesterday's lesson, our equation for slope is y2 minus y1 over x2 minus x1. So we'll go through. It doesn't matter which one you pick to be the 1 or the 2. So we'll do 5 minus 2 over -3 minus 6. And that will work out to be 3 over -3 minus 6 is like -3 plus -6, which will be a -9. And that gives us -1/3. So that is our slope. Our slope is -1/3. We have 2 points that we get to choose from, so let's plug that into our equation. Y minus y1 equals m x minus x1. Again, whichever one you choose for y1 or x1, it doesn't really matter. It would end up being the same line. So I'm going to go y minus 5 equals -1/3 x minus -3. Minus a -3 would become plus a +3. And there we have written our equation of the line. Now let's say it wanted us to graph that. Again, our equation we just found was y minus 5 equals -1/3 x plus 3. So the first thing we're going to do is write out everything. I know my slope is -1/3, and I know the point I was looking at, since it's supposed to be x minus x1, since there's a plus there, it's going to be a -3. And our y, it'll be a +5. So we'll start at that point, -3, +5. So we will go left 3 on my x-axis, up 5 on my y-axis, 1, 2, 3, 4, 5. And that will be my first point. Then my slope tells me to go down 1 and right 3 from that point. Down 1 and right 3. Go as many times as you want until you have enough to draw a beautiful line through. And that's our equation of the line drawn in. Next, we'll be looking at standard form. Standard form is when ax plus by equals c. A and b are not 0, and you really only use this to find the intercepts. In order to find intercepts, you'll make x equals 0 and you'll make y equals 0 to get those different intercepts. So let's work that out, find the intercepts. In order to find the y-intercept, or what y equals, we're going to plug in 0 for x. So -3 times 0 plus 2y equals 6. -3 times 0 is 0, so this is 2y equals equals 6. And then we'll divide by 2, y equals 3. So that's our y-intercept. Then if we want to go on and find our x-intercept, we'll do the opposite. We will make y equals 0. 3x plus 2 times 0 equals 6. So that's -3x equals 6. We'll divide by -3 on both sides, and we'll get that x equals -2. So those are our intercepts. Remember, an intercept is where it crosses the axis. So it crosses the y-axis at 3, and it crosses the x-axis at -2. Moving on, they ask us to graph that. We can go ahead and just look at our intercepts. We knew in our last equation the y-intercept was at 3 and the x-intercept was at -2. So looking at our axes, x-axis is horizontal, y-axis is vertical, we'll plot those points. So y equals 3 will be at 3 in the y-axis. X equals -2 will be at -2 in the x-axis. And we'll draw our line through. And bada bing, bada boom, you're done. So now we know 3 different forms of equations of the line: point-slope form, slope-intercept form, and standard form. So let's look and see which one we would want to use here. Write an equation of the line with a y-intercept of -5 and a slope of 7. So here we are given an intercept, we are given a slope, so we should probably use slope-intercept form. Y equals mx plus b. Plug in everything. Remember, your slope is m, y equals 7x, plus a -5 is the same as -5. Now if we needed to graph that, again our equation was y equals 7x minus 5. We would start at -5 in our y-axis. Remember, our y is our vertical axis. 1, 2, 3, 4, 5. And then our slope is 7, but 7 written as a fraction is 7 over 1. So we will go up 7 and write 1. Up 1, 2, 3, 4, 5, 6, 7, and write 1. From there you can draw, ooh, not very nice. It's kind of hard to draw these lines very prettily. Prettily? I'm not sure that's a word. Beautifully? That's a better word. Here we go. Let's do it this way. Ding! And there we have our line. Now please remember, if this video is going too fast, you pause, you rewind, you rewatch a certain section. It gives you control of how much you're watching. When we talk about parallel and perpendicular lines, we're going to be looking at the slope. If 2 different lines have the same slope, they're parallel. Parallel means that these lines never cross. Opposite reciprocals means they're perpendicular, which means that they cross at exactly one point that creates a right angle. And that is about as far as we're going to go into it. So remember, same slope parallel, opposite reciprocal, perpendicular. Scatter plots. We're going to get into scatter plot graphs, and they're going to ask you about correlations. Correlations, they're kind of like slope. If the dots go up, that is a positive correlation. If the dots on your scatter plot go down, that is a negative correlation. If your dots have no pattern whatsoever, that is no correlation. And then the last thing you'll look at is whether the correlation is weak or strong. If it's weak, the dots will be widespread. If it's strong, the dots will be very, very close together. Here we have an example of a scatter plot that seems to have a very strong positive correlation. That's because clearly the dots are going upward and they're very tight together. We have a lot of data. So it wants us to estimate a line of best fit. We have 3 different forms of lines we could write: y-intercept, standard form, slope-intercept, and point-slope form. So we could find a y-intercept, we could find a slope, we could find a point, we could find 2 intercepts. There are many different ways that we could go about this. I like using slope-intercept form, so I try, when I draw my line in, it says the line of best fit. So our job is to try to take this line and make it look like it goes through most of the points. So right here to me kind of looks like it goes through those points at a very nice spot. So there are two ways we could do this. We could do our slope-intercept form, y equals mx plus b. In order to find slope, we do rise over run. We went up 1 and right 1. So y equals 1 over 1x, and our y-intercept, where it crosses the y-axis, is 0, plus 0. So y equals x. We also could have gone through and used 2 points. We clearly have this point here and this point here that we could have used. Our first point is 2, 2. Our second point is 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Now we could calculate our slope from that. M equals 5 minus 2 over 5 minus 2, which is 3 over 3. Notice that even though we decided to find the slope a different way, it's still the same thing. It's still 1. Now we'll plug it into our point slope form. And we get y minus 5 equals 1x minus 5. And we are done. Congratulations, we made it through the second video. So, for our joke today, what did the ranch say when someone opened the refrigerator door? Ah! Close the door! I'm dressing!